Oh yeah, we can start. So we're just gonna quickly do some introductions and then we'll get into some stuff. Hi, I'm Akul. I went to high school in Georgia at the Westminster schools. I am currently at Emory doing finance and math, and I did science Olympiad for 4 years, and I did some individual Olympiads. And I also taught natural history in a museum in North Georgia, and I did fossils at States. So that's sort of my background there.
Yep, sort of same for me. I also went to Westminster. I'm here at Georgia Tech doing majoring in mechanical engineering with a minor in computer science. I also did Science Olympiad for 4 years. I've helped with over 20, I want to say, tournaments now. I also did states or fossils at states along with some other ID events as well.
Okay.
So yes.
So this is sort of like the itinerary for this meeting today, or like this workshop, and we're going to quickly go over some of the rules, then some topics that when we took the event we found really difficult, and then we're going to just look over some questions that are like pretty standard or stock, and we're going to give our advice and then some other resources. So the rules.
Yeah, so to start off the rule sheet, there are a couple common topics that come up that the rule sheet sort of dictate on it. So one of them is, of course, IDing fossils, which is part of the ID event. And additionally, there's stuff about past ecosystems and environments and how those fossils relate to those. And also the age within these ecosystems and the fossils as a whole. So ways to determine that and how they fit together evolutionarily within the geological time history of Earth. So some of the things that are allowed is a 3-ring binder of any size. You can have a magnifying glass. This may or may not be useful depending on how the event is run. If there are stations with actual fossil specimens, magnifying glasses may be useful for seeing small features, but otherwise not so useful, but it doesn't hurt to have. Additionally, same goes for a field guide. Ideally, the binder has everything and you're most familiar with your binder, but a field guide can be helpful for having those small details. And finally, you can have a official list. So the fossils which you're supposed to know, which are detailed within the rules, you can have that printed out as well. So yeah, to move on to some difficult topics that we found difficult at least, and hopefully are helpful for y'all to know. So the first difficult topic really is tooth ID. So assuming that you've got an ID of actual fossils down, tooth ID comes up semi-rarely, but when it does, it is quite difficult. So some common teeth that you should know. One is for the Basilosaurus. Here, the, I guess, key characteristic is these wavy teeth that you can see on the very top, sort of like peaks of a mountain range. And that's the key identifying factor here. Additionally, the second one is for Batoidea. This is sort of the predecessor to stingrays, and you can see these comb-like teeth, which are helpful for the way that these animals eat and filter out food. And the really key giveaway here is that it looks like a hair comb. Secondly, within Teeth ID, some of the key common topics that come up are sort of how the teeth relate to the diet of the animal itself. So here we can see the difference between the woolly mammoth on the left and a mastodon on the right. So here on the left, the woolly mammoth's teeth are a lot more flat, a lot more suited to eating herbage and eating plants foliage. Whereas on the right, the mastodon's teeth are more peaky and less suited for that. So you might see a more omnivorous diet in that case. Same thing goes for ecus and mesohippus. So mesohippus are predecessors for modern day horses, whereas ecus is modern day horses. And you can see these very flat, grindy teeth for horses, equus, and more peak-style teeth for Mesohippus, which is also, again, an indicator of their diet. And finally, I think the hardest differentiation between all of them is between a Mosasaurus and a Tyrannosaurus Rex. I don't have that many good tips. The one thing that we used to go by is just the gradient of the teeth. This does, of course, differ by fossilification of the tooth itself, but most commonly, T-Rex teeth have a sort of solid color, whereas Mosasaurus have a gradient to them. And additionally, T-Rex teeth curve slightly more. It's pretty hard to tell, but yeah.
So I guess another topic that comes up a good amount, and this is like sort of less like fossils, less paleontology, more geology, is evolution and geological history. So firstly, like one differentiate, they might ask like, what is the for earliest life on Earth? So there's a bunch of different answers to that. So it depends on how they ask it. If they're just talking about oldest evidence of life, we have a graphite grain inside zircon. And in general, when you see zircon, it's going to be something old because just zircon's formation patterns and the fact that zircon can have uranium sometimes in it. So it's really easy to date stuff within a zircon too. So the Jack Hills formation is like the oldest evidence of life, but that's like an isolated example. Like it's literally a grain of graphite versus the oldest like pure like a stratigraphic layer. So like if we're looking like a large area of life is in Greenland, and it's looking at like a meta sedimentary layer. So it's like it's a collected sediments that have gone under some form of diagenesis or like some form of change, and there we can have evidence of life. But most oftenly they're going to ask about like the earliest known direct form of life, like not just carbon evidence, but like a fossil. It's not a pure fossil, but like a fossil. So that's like the stromatolites, and the most famous one is like the ones off the western coast of Australia, which is this right here. And stromatolites are microbial mats that are like mixed with sediments and get fossilized, and they end up getting preserved in a geyserite, which is just a fancy sedimentary rock. And most commonly, they form in hypersaline environments. And stromatolites, like understanding them was always confusing to me at first, because like it's a fossil, but it's not really a fossil at the same time. It's like the microbes, the cyanobacteria, which is what stromatolites are, preserved. And one thing that I used to mix them up with is banded iron formations, which is another piece of evidence for the cyanobacteria. But this is just proof that oxygen exists within the atmosphere. And so you have layers of the red layers are high in iron oxide, while the gray layers are shirts that are low in iron oxide. So they're very dark. They're like just pure iron, so very dark, versus the bright red of the iron oxide. And understanding banded iron formations and just stromatolites give us like good context of how life changes over this geological timescale. And in general, just refer to the Science Olympia geological timescale, because there's a bunch of debated stuff, and this is going to be like what your tests are going to be written off of. So, like when we're talking about like a lot of stuff is focused. A lot of fossil resources are focused from Paleozoic to Cenozoic. So I also want to highlight some of the Precambrian stuff. Precambrian is before all that, like the major diversification of life. So if we go here, like Hadean, it was really hot, and it literally comes from the word Hades. And then Archaean, like talking about old, and then that's when the kingdoms of Bacteria and Archaea split apart. And Archaeans defined sort of by the presence or lack of cyanobacteria. So when cyanobacteria, which are bacteria that can do photosynthesis, start producing a lot of free oxygen to the atmosphere, that's what really pushes us into the Proterozoic. Proterozoic is when Animalia starts coming, and then it's not, so there is life, but it's not very diversified. So it's corals and jellies for the most part. But the Cambrian explosion is what sort of defines like the Phanerozoic like eon, because like these three can be called the Phanerozoic, And what defines it is that diversification of life, not just the fact that life exists, if that sort of makes sense. And then this is something that's going to come up too, is when do certain forms of life start appearing? So you have, so this is what we talked about, the bacterias, and then it was like corals and fungi, and then the Cambrian explosion introduced so much more stuff. And yeah. And then part of the fact of life is that a lot of them end up dying, and they die in, for the most part, things will die in pretty noticeable waves or patterns. And we have five big like major events, and these five here, the Ordovician, Silurian, Late Devonian, Permian, Triassic, Jurassic, and Cretaceous Paleogene, also known as the KT extinction, are all pretty big mass dying events, and they come up pretty frequently, especially like ranking percentages of what died. So I'm not gonna go like overall, but there's like in here you can see like all the percentages of like what percent of species died, and that's something they'll ask, like rank them from percentage like species survived. And then another thing is that you'll oftentimes see fossils tests talk about six major mass extinctions, and this one is the Holocene extinction, and it's still debated, but a lot of tests will ask about it, and is talking about how currently we have a large rate of extinctions and stuff like that. And then topic 3 that we thought was confusing when me and Victor were discussing this was just like ornithischian versus Saurischian hips, and like what does that even mean, right? So this nomenclature was first like postulated or first like discussed when we didn't really know much about like dinosaurs. Like there were like I think like 20 to 30 dinosaur species identified at this time. So we looked at modern bird anatomy, and from there we were like the pubis and the ischium, which are just bones in like the pelvis area. Those bones are parallel. So we were like, oh, just like modern day birds. But then when we look at other dinosaurs, and we noticed this parallel pubis ischium, like complex in mostly herbivorous, right? So Stegosaurus and like some of their sauropods and like Brachiosaurus, stuff like that. We notice that parallel pubis issue. Then when we're going to the Saurischian pelvis, this is when the pubis and ischium, I guess the best way to explain it, are perpendicular, like they're not in line with each other. And like this was mostly on predatory dinosaurs. So think about like T-Rex and stuff like that. And one thing that is confusing about this though, like, is that the fact that birds evolved from the lizard hips, not the bird hips, right? So the ischium rotation happened twice. So like in this image here, this ischium rotated here. Like I think there's a pen tool. Yeah, let's turn on the pen. So like this ischium rotated again. There's a second time it rotates, right? So, and that's how modern birds came. So when dinosaurs, so it was like mostly predatory dinosaurs that evolved into modern day birds. And in that, the ischium rotates back. So it's not actually these dinosaurs, that evolved. Instead, it's these ones, and they had the rotation of the ischium.
Yeah, so to cover some of the common questions that we saw while we were doing fossils.
Oh yeah, and
the note said that these are pulled from YJA tests. Some of these are from other sources. So this is from the Earth Science Camp open exam, but this one is mostly looking at Steno's laws. So even though the event is named fossils, the development of geologic strata is also very important to understanding geological history and the time frame within which fossils exist. So Steno's laws allow us to sort of examine how the age of certain features. So here we're looking at feature 1, structure 1, within the image on the left, which is a dike that is going through some of the layers here below L. So because it is going through some of the layers, we know that it must be younger than K, which is the sort of the youngest layer which it goes through. So it must be younger than that. And if we look on the table on the right here, we see that structure K has an age of 2.7 or 270 million years ago. So given that we know that structure 1 must be younger, we can deduce that it is 250 billion years ago.
And yeah, just to add on to what Victor said, like even though this isn't from a fossils exam, every fossil exam will ask one Steno's law question basically, and it's like just showing that do you understand relative dating? Like, do you understand how things relate to each other on a time scale? So I would say like this question is probably like one of the most common questions you'll see. Something we have to do something like this.
Yep. And then a second common question here is coming back to the tooth ID. So here in A, or in this question, we're asked to identify the specimens and to provide their closest modern relative. So this is both asking us to ID the teeth and to also understand how evolutionary history and how these fossils relate. So within A, if we recall back to the previous slides, we see that that is a Basilosaurus tooth, given that like sort of peaky vision or peaky identification and sort of it looks like a mountain range. And the closest modern relative would be a whale. For specimen B, we see that that is a Mesohippus, sort of coming back to that previous slide, and the closest modern relative would be a horse. So equine evolution is pretty common on exams as well, so I'll make sure to understand that. And C, we see a Megacerops jaw, bottom jaw. This is the closest modern relative would be a rhino for that. And then in part D, we see that we have that not mammoth. What's it called?
The mastodon.
Yeah, mastodon tooth. And the closest modern relative would be an elephant for that.
And then, oh, this is blurrier than I expected, but hopefully you guys can read it. It's basically asking what the age of, right? And that's sort of like a test on do you do you understand which life forms were dominant during which periods, right? So Devonian, and this is something that comes up often too, and it gives you also just like a sense of perspective of each period. So the Devonian was the age of the fishes, because a lot of diversification, like fish existed before the Devonian, but they were like at the top peak of the food chain and also the most and extremely diversified within the Devonian period. Mesozoic is age of the reptiles, and Mesozoic is sort of defined by their a large amount of dinosaurs. So, and yeah, in the sauropod of dinosaur reptile. So that's sort of where we go there. But there's also some arguments where people say that it's the age of the conifer. So both work there, but in general, assume reptile. Cenozoic, which is what we're currently in, is the age of the mammal. Following the dinosaurs, the mammals were the dominant life form, so it's the age of the mammal. And then Carboniferous is when amphibians were true, like getting their strides and were one of the most diversified at that time. So Carboniferous is the age of the amphibian. And then index fossils. Index fossils are something they'll ask about commonly, and index fossils go back to the idea of relative dating. So similar to the Steno's law thing, we can use index fossils to determine how old something is or how something was like built, sort of. Like we can determine also like stuff like Wagner's theory is dependent on Wagner's theory of continental drift is dependent on this idea of index fossils. So I would say the two things that you need, two characteristics of index fossils is confined in geographic time, unconfined in geo in in geological time they need to be confined, but in geography they need to be unconfined. So basically what that means is like you should be able to find them in a lot of areas, because if it's in one area it's not going to be an effective index fossil. So if they're widespread, and also if they were only alive, or if all the fossils found were from a relatively small period within geological time, I think one really good example, this is one of the trilobites cryptolithis. That's like a pretty strong example of what an index fossil should be.
Yeah, and then I guess for to add on more to the index fossil talk, um, one thing which we haven't talked about is Lagerstauden. This comes up pretty, excuse me, pretty regularly, even though it's not part of the ID part. So sort of understanding, having a map of Lagerstauden is very helpful in understanding what each contains, and sort of the timescale with which each encapsulates is also very helpful. So to move on to some tips from a veteran, I can talk about this. So the number one thing is just to practice ID. You should not be having to, I guess, flip through your binder or you should know what a fossil is instantaneously. This saves you a massive amount of time. It gives you more time to work on the actual questions. And the better you are at ID, the more you can the more accurately you can, or the more opportunities you get to answer the other questions correctly. Because unfortunately for ID events, it can be sort of a double jeopardy, where if you don't get the ID correct, you will miss all of this other secondary questions. So it is the most important and pertinent thing to get the ID down. The second tip is to make your own binder. And this allows you to organize your binder in a way that's efficient for you. So most efficient in two ways. One, being able to find each fossil quickly, and two, being able to find information about each fossil quickly. So if you have you can order the timescale, I guess the environments with which each fossil develops, and sort of, I guess another thing is like diet in whatever order you want and is most effective for you. And then above at a higher level than that, ordering the fossils with the order that works for you. So whether that's going by the provided list, going by a different order, alphabetical order, all of these, figure out a way that works for you and implement it. And the last tip is just practice tests. Because fossils has so many different things, the only way to figure out what you don't know is to just take a bunch of practice tests. You will see your holes and misunderstandings within ID and other topics, and this will allow you to either add on to your binder or add on to your own knowledge about these separate topics, and will make you much better at fossils. And there really is no substitute for just taking practice tests and seeing what is missing.
Yeah, and I agree on that. And so some additional resources for doing that. I think speaking on this point about practice tests, SciOly Wiki, because there's on the SciOly Wiki, there's two forms of practice tests. You have practice tests from like the test exchange, like something called the test exchange, which is like community written tests. But then you also, if you go on the wiki itself, it's sort of confusing. SciOly Wiki is a forum, and within the forum, there's like community written tests. But then you can also find a database of like of official tournament tests on the SciOly Wiki, so it gives you access to that. And it's also a great starting point because it basically sums up all the points of the event into one list, and it gives you a point to start off of. And then from there, areas of research. And one thing when we were doing fossils is our go-to source when we were doing research was Wikipedia. I know it's not oftentimes the most academic source, but in something like fossils, we're not looking for it's since like we said, it's very horizontal. The vertical depth doesn't need to be that extreme. What we're instead looking for is like broad information versus something that's hyper specific. And once you feel like you have all that broad information, you can go on to things like other websites, more advanced websites, or what we like doing, and something that I really enjoyed doing was looking at textbooks too. So I think if you're starting off with textbooks, after you do Wikipedia, after all this stuff, and especially if you feel like you're struggling with the geology of it, like understanding how stenos works, understanding how fossil assemblages work, modes of preservation, I really recommend Tarbuck Earth Science. It was a book that I had a lot of experience with in high school, and it covers the geology in a pretty efficient and pretty cogent way, so it's easy to understand. And if you feel like you have a good grasp of geology already, and you want to sort of just take that further. You want to take your geology and like some of this more physical and parts of paleontology higher, there's Marshak, which is another earth science textbook that's just slightly more advanced. Both are really good. Tarbuck is better for beginners, and but I think the most important resource, like if you can only use one of these, the ID bot on Discord, it is basically a Discord bot. I don't know how familiar you guys are with Discord, but it's basically like Slack almost, and it's or Microsoft Teams, and it's sort of like a the bot there allows you to it'll give you images, like random images of different fossils. So basically it's giving you just random images and you type it in and it'll let you practice, and it's a pretty efficient way to practice too because it allows for new images. I think one of the other common ways people practice is flashcards, but the issue with flashcards is you're not seeing as many images of fossils as you'd like, versus this is like scraping the internet and scraping like pre-checked databases to help you ID.
Yeah, I can second the recommendation for the ID bot. Some ways to make your IDing more efficient is you can also narrow down what the bot gives you by phylum. I highly recommend when you're learning ID to just go by phylum first. So sort of nail down each phylum before moving on to the next. And then that way before a tournament, for example, you can brush up by just doing all of them. But if you do all of them at first, you will see some fossils very infrequently just based off of how many pictures there are in the database, etc. So I recommend going by phylum. And same thing for Tarbuck too. You don't have to read the entire textbook, but several chapters are very helpful for fossils itself. So sort of looking at the geological time history and also various rules around stenos, etc.
Yeah, and then I agree with that Tarbuck thing. I personally enjoyed reading the whole textbook, but Tarbuck, it's gonna be for the fossils application. I think reading certain things like tectonic plates and like rocks and minerals, like understanding some of the common minerals within fossils, is gonna be the most useful.
Yep. So we'll open the floor for any questions. There's already one question for the link to the ID bot. I can drop that. It's run by mostly person. He's a great dude. It's a nice community as well. So if you're trying to sort of get more involved, I would recommend that.
And I can also link the books,
Wait,
or
these are
I can type the names. Let me make sure I get the right name.
yeah. It would be very bad and very not good if you were to just Google the textbooks and look for PDFs of them online because they most definitely don't exist and definitely aren't cheaper than buying the actual textbook.
Yeah, I second that. It would be really bad if you Googled the name with the word PDF for a very commonly used textbook.
Yep. I guess second or another question. We'll go, I guess, in chronological order. So, how many pages did we have for our binder? We
That was
shot for around 2 to 3 per fossil. So that added up to around 600 in total, including sections on the other topics. So I guess one thing, a stake tip that I can give, Akul was very good about reading Tarbook. I wasn't. So we included the glossary from Tarbook in our binder, which is just very helpful for random trivia, which not as good tests can sometimes include. Anything you want to add, Akul, to that?
I would say that the glossary was really helpful because there's a lot of niche terms. So having that glossary was helpful, and the glossary did add a pretty big page count, but I think its return on investment was better. I'm looking at some of the other questions. What topics get tested on? I would say ID is like going to be your biggest one, and then once you ID, it really depends on like the era. If it's a dinosaur, everything's on the table. So like they might ask about footprints, like foot patterns. They've asked about foot patterns before, size of the dinosaur. So if it's a dinosaur, because so much is like dinosaurs were in popular culture a lot, especially in the 90s. So like there's a lot of information on dinosaurs. So that anything is basically open. You'll see any type of question about dinosaurs, right? But if it's like a vertebrate or invertebrate, like when you're talking about trilobites, the biggest things can be diet and mode of life. So like trilobites, eurypterids, they're gonna be asking about that. And then like some of the corals and stuff like that, they're gonna be asking about coral branch theory and like how do they branch. Like they're gonna ask a lot about its family. Like the more generic it is, or the more popular something is, or the more it's like well known, is the more things can be on the table. I guess formulas. There's formulas in the rules about like dinosaur size and stuff, and then I guess like knowing your half life formula, like the differential equation with E, like natural growth, that's pretty important formula wise, and then the other ones are there.
Yeah, and then to come back to the key topics as well, most tests will at least focus on evolutionary history in some way. So whether that is the evolutionary history of plants or the evolutionary history of animals from water to land. So one of the most key fossils that comes up a bunch, and you should understand how it fits within history and is contextualized within it, is Tiktaalik. I can't recommend just looking up Tiktaalik and really focusing and nailing down that and working more off of that. For formula, yes, half-life dating is probably the most common thing that'll come up. Um, Personally, we weren't big fans of, I guess, footprints and trackways. We didn't see it too commonly, and also, just as a rule of thumb, it's pretty variable in general, and it's not very good. So yeah.
And then I'm seeing this question about like age range. I think it's really hard to have like a very specific age range because age range is something that is because these animals exist for a period of time. There's fossils that range in like for 50,000 years, and in general, the Wikipedia one is like pretty accurate. And if you want something more precise, if we're looking at the precision for that is that we clicked on the because all everything on Wikipedia you can see where it's cited from. So if you want to be like really precise about it, you can click on the backlink for where they cited that time, and it'll oftentimes be from a research paper that's a lot more in depth, and would give you the time on that. And I think this is the recording being shared. Victor, do you know
Yes,
if it's
the recording will be shared.
I can link the test. Let me link the test exchange. I should have done that. My bad.
Yeah, and then for the 600 pages for B and C, B does have slightly less fossils, so by default, the page count will be slightly less. Or actually, sorry, it might be the same this year. Actually, yeah. So I think if anything, Division B would have more pages because it might be a little bit harder for someone in Division B to sort of get a grasp of the materials. They have less, by default, they have less time that they've seen the material, that they've worked with it. So having a little bit more notes there could be helpful in that case.
And okay, so for the binder, so for plant fossils, I think Victor, you did plant fossil. Victor did more of the plant fossils. I did a lot more of the geology and like animal stuff. So I think Victor can elaborate on that.
Yeah, plant fossils, some of the leaf ID is hard. So the difference between, I remember Achair and Populus was hard for me. The key differentiator there is just the number of tips. If I remember correctly, Achair has 3 tips, 3 to 5, whereas Populus is more bulbous. That's the key differentiator. And additionally, for plant fossils, understanding how they are fossilized and additionally how they contribute to their ecosystems is very important. So sort of how do they benefit their ecosystems? How did they gain nutrition? And sort of what canopy coverage were they providing? And some other trivia such as just generally height, etc. And their ranges came up pretty commonly for fossils. And to add on more to the age range thing, most test writers will just go by, well, most test writers will give a margin of error to students when grading, and most test writers understand that Wikipedia is the most common source. So they'll most likely stick with Wikipedia or whatever a field guide gives as well.
And just to add on to plant fossils, Victor touched on it, but just like that part there is um what is that? It was like, oh yeah, so like typically if the fossil is famous for its leaves, it's gonna be like a carbon film. And if it's more famous for like its stem or like its vascular tissue, then you're gonna see like silicates that that replace the organic tissue. I think in general, it's it's not very important, but it's a good idea to also brush up on like basic anatomy about plants and like animals, because when they refer to certain bones or certain things, it's important to know like, oh, this is that, or like if they refer to a vascular tissue of a plant, knowing that like, oh, that's the xylem and the phloem or something like that, right? So I think having that and chemical, I'll just go down the list. Wait, so then station and time in between easier. I think you like be ready to move at the station. It's like don't continue working till time is done. Like if you have, let's say 10 or I don't know, like if you have 5 minutes per station, I think like at like the 10-second or the 5-second mark, like be ready to move. Like don't wait until the buzzer and then you move. And chemical components of fossils, they will actually they ask that a good amount. Like in general, it's gonna be a silicate, so like it's gonna be some form of a silicate mineral. But they're gonna ask about, especially like special forms of fossilization. They might ask about like the chemical composition of that mineral, because at the end of the day, this is just like a mineralization. A lot of them, or it's a sediment thing. So like knowing different rocks, like their formations as well.
Yeah, and then to, I guess, make sure that we didn't miss anything. Another question was, what are some things we should include in our binder for each fossil? So yeah, age, period, location are some of the most important things. Uh, Diet was another thing we included on our binder. I don't have our binder pulled up. I can go find it, but uh,
I, th- I think off memory too, we had like we had, first of all, its scientific name, common name, etymology of both, so like knowing where they came from.
oh yeah,
Then we had,
you should have the entire taxonomies because
yeah,
sometimes uh, the test will ask you to taxonomically relate different fossils, and being able to understand that is important.
what else? We also had, so we had mode of life. So was it stationary? Was it at the bottom of the ocean? And then diet. So what does it eat and like how does it eat? So did it filter feed, stuff like that? Physical size descriptors, like it was this big, this shape, this like or like this weight is something that we included. Physical size descriptors, geographical location. Then we had something that was more, that they always like they might throw in like some like cultural reference. So like what's a common, if it's like a famous fossil like the Archaeopteryx, they might ask about the Berlin formation, the Berlin specimen, or like they're gonna ask about like notable samples or
Yeah,
notable
like
fossils.
Sue for the T-Rex.
Two for the
And
T-Rex.
additionally, to add on that too, like sometimes the fossils were involved in other cultural things. So like the Bone Wars was something that sometimes came up, and understanding how that was fought and the history of that was helpful at times.
Um, yeah, the history of, oh, and then like if the dinosaur itself is like important like to the history of paleontology. So like you have the iguanodon, which is like the first dinosaur. That's notable. And so I would say like the you should aim for, on a binder for binder, like you should have one or two photos, maybe an anatomy diagram or like an important diagram related to the thing that they'll ask about. Especially for trilobites, like having a trilobite anatomy diagram is really important because they
Oh
always
yeah.
ask about trilobite anatomy. But so they're like knowing that, knowing how they eat, where they lived, how they lived, like the general biome they lived in, those come up often, like their scientific name or like their taxonomy and like why it's named the way it is, the etymology, like what does it mean is important. And then knowing the, like what is it, culturally notable specimens, um, is it the state fossil of something? Is it important in some tradition? Is it used in some other way outside of paleontology? outside of science, that's also something they'll ask.
Yeah, that's a great summary. And really, the way that you figure out what you should add to your binder is just by taking practice tests. You should have sort of, you can go off our recommendations for base things you can have, but at the end of the day, things will pop up that inevitably are not included in your binder. And being able to iterate and change your binder is very helpful. It unfortunately takes a lot of paper, but it's just the way it has to be, where you have to iterate on your binder, sort of add on more pages, change pages, etc.
And sort of on that thing of like, I wouldn't say that you should do a full, like you shouldn't have someone who's an expert in one thing and an expert in another, and like they don't have overlap. Like I was still familiar with plant fossils, even though me and Victor did fossils together. Victor knew the plant fossils better than me, but I could still do plant fossil stuff on my own. And like same thing, Victor, I knew some of the animal fossils and the geology better than Victor, but he could still do that on his own. So I think that it's they shouldn't be just like experts, but they should have specializations, but and be specialized. They should be specialized, but also general.
Yeah, to add on that to add on to that a little bit more, especially for a exam that is a station format, it's very helpful to have two people who know what's happening, so that way you can have two people simultaneously working on a station, because stations will most commonly be focused on one genre of question, one I guess one topic. So if one person is specialized, and if each person is an expert and there's no overlap, it'll be a huge burden on that one person during that station. Yeah, let me look through, make sure we didn't miss any questions. I saw someone had their hand raised. Were we able to get to your question? I'll take that as a yes. Um, what other things? Cool. Do you remember what field guide we used?
Let me check. I think we used the Smithsonian, or
I want to say it was the Smithsonian too. We
I
rarely, for fossils, the field guide wasn't that helpful for us. It's more helpful for other ID events, but we personally believe less so for fossils.
wait. I think it was actually Audubon. I think it was Audubon.
Oh yeah, well, we might have bought both, and then
I think we bought both. Yeah.
pick
But
and
I
choose.
think we used Audubon in the exams.
Yeah,
Um,
don't worry too much about the field guides. We didn't find it helpful, really. And then to add on to the tips about stations, be ready to move at an instant, like Akul was saying, but also keep in mind that sometimes you can keep working on the station even after you move. So if you've already ID'd the fossil, which is again coming back to why we stress ID so much, being able to instantaneously identify the fossil allows you to keep answering those questions even after you've moved past that station, and allows you to just have more time in general as well.
and answering one of the questions in the chat. If you're should you split the questions between partners in a station? And I think it once you it depends, because oftentimes we get to like once you get the ID down, I would say yeah, because like it's a lot of the information's condensed on one page, because if once you identify it, you flip to that page, so you can do like something where you can split the questions. But in other contexts, um it might be better if like both partners work on something at the same time, especially if it's a station with like one or two math problems. Like they'll sometimes have a station where it's like just a few math problems. Having two partners work on that math problem to ensure that it's correct is sometimes more optimal. Victor?
Yeah, I definitely agree with that. And to add on a little bit more, you only have one binder, so it's sort of inevitable that you'll be looking at the same thing at the same time sometimes. So um, the way that Cole and I did it is, if we had enough time, we would sort of someone will work top to bottom, the other person will work bottom to top, and then if we had enough time, we just check each other's answers at the end. And a lot of that really comes down as well to just the partners and how they're comfortable working with each other. I wouldn't recommend enforcing a certain solution. If you are more comfortable working in a certain way, you should work in that certain way and do what's most efficient for you.
Oh yeah, I agree with that. I think at the end of the day, some of that stuff for like splitting questions between partners is like that's also one of the importance of practice tests is that you can in a non-competition setting figure some of these out, like figure like how do the partners synergize, how do you synergize with your partner and like that.
Yeah. Like for example, when we ornithology is most recent in my memory, but when Akula and I did ornithology together, I would usually idea Akula would flip to it in the binder and we'd start working that way because um, that was just the most efficient for us. Any other questions? Um, yeah, if that's it for questions, I guess one thing that we can add on to, or I want to add on to, is for the common topics. Um, One thing that came up pretty often was the marine sort of environment and, or I guess the modes of life and mobility. Sometimes I had a little bit of trouble understanding between like benthic and the other zones within an ocean. So having a map for that is pretty helpful.
Yeah, and then also having a diagrams, especially in these situations, is a lot more helpful than like just straight notes, like especially on anatomy, because some animals, like the really popular animals, they'll like asking anatomy on, so like Stegosaurus, they're gonna ask about like what do you call those plates and stuff like that. And we use the same format for invertebrates versus vertebrates, but the information, because mode of preservation is different, the information is also different. So like for stuff like invertebrates, you can also you can tell like what environment they're preserved in based on like the rock that they're buried in. So if it's like small, if the grains are small or big, you can determine what their environment was based on that. And for vertebrates though, you can determine a lot more based on there's more better preserved features. So like you can see like head, claws, like mouth, teeth, and stuff like that, which you don't get in invertebrates. So it's just based on preservation, what we know more about them. So I think keeping the same format's good, but like it's gonna be natural that you're gonna have more information in one category versus the other, for depending on vertebrate and vertebrate.
Yeah, I think I just add on that to that too. Fossils is, I guess, in the realm of ID events. I think ID events are one of the best events where you're at IDing and sort of you don't have to memorize everything. You're relying on your binder in that sense. So formatting your binder in whatever way works for you is the best, and figuring out which way you want to do differentiations helps.
And about that cladograms, like it might like my general rule of thumb is like it's better to have it than not use it, because I think in our binder there might have been some pages we never flipped to, but like they totally could have came up on a question, and just having that in there was good. Because but that's really up to you guys as well. If like if you like are absolutely not finding it in useful at all, then it might be worth removing. But I guess my general rule of thumb is just to like, keep it in there and have it just in case.
Yeah, I don't think we had a cladogram necessarily. It's very hard to have a cladogram with every fossil on the list, but we understood how dichotomous trees are formed and how cladograms give us information about the most common recent ancestor, how each um, different animal or plant is related. And because most likely the exam will give you the cladogram and ask you questions specific to it. So that's what we found most helpful.
And I agree with that. And also the way the fossils list is oriented, or like way it's built, will like have natural, I guess, like it's based on evolution. So like the most modern stuff is going to be at the end of the list. The newer like groups are going to be at, or the newer groups are at the end of the list. The older groups are at the top, and a lot of some of the cladogram stuff can be sort of visualized from that. Not all of it, but like some of it.
Yeah. Oh yeah, now that I look at the list as well, trace fossils, we just included examples. They don't come up too commonly. Uh, we were very bad about IDing between, at least I was very bad about IDing between borings, burrows, and tubes. I still don't understand it myself. Um,
Um, I
yeah.
would say,
For quality of binder, please do not get a D-ring binder. D-ring binders are really bad for flipping. Get an O-ring binder. That is the best tip I can give. But at least in my experience, binders they're like a commodity item. Their quality doesn't differ too much. Just be gentle with it. Don't toss it around. The most common thing that'll happen is that your pages will rip, and Akul and I fixed that by just either using tape or just reprinting the pages.
oh,
And yeah,
and then
get a
wait,
good quality hole punch because you'll be hole punching 600 pages,
yeah,
and it's a lot easier if you have a hole punch that can do a lot of pages at once.
I was about to say that I think more than the binder, what matters more is your hole puncher, because there were days where the hole puncher would just not work, and it was like genuine panic because we had like 600 pages. Also for printing, don't print all the pages at once. I would say is like print like batches of like 50 to 100, so that way it's like processed easier. It's like not gonna. It had lower risk of jamming as well. Like that was something that happened a good amount when we were printing our binders. So like it's like printed in smaller groups.
Oh yeah, if the print fails for whatever reason, it's a lot easier to reprint a 50-page batch than to wait for than to deduce what went wrong, like where it stopped printing in a 600-page batch. And oh, when we say 600 pages too, I believe this was 600 pages back and front, so it came out to around 300 pages of paper, I want to say.
Yeah,
Um, but yeah, do batch prints. Get a decent hole puncher. If you don't have a decent hole puncher, be conservative. I think like one of the most common ones was a swing line one in our school, and I would have to do 20 pages at a time. So it's kind of slow, but just be methodical. Put on some music, and it's like maybe an hour's work, half an hour's work.
that can be therapeutic.
Yeah, especially when you take out the like the holes that you punched out at the very end. I don't know. That was one of my favorite parts. Anyways, yeah. If there are no more questions, I think we'll call it there. Feel free to reach out to either of us or GT SciOly as a whole if you have any more questions.